Okay, so should hide the screen. I prepared here something for us, but okay. So today we will talk about monad. So we have our nullary function, and we want to combine it with function. You will probably see something like that, where M is monad type or monadic type, and B is known. Actually, because we know that a nullary function is a kind, or is some specific specialization of f type, where f is some type generator. So actually we just rename it to n, and so our nullary function can be written as m of b or a. Yeah, so it doesn't matter. This is just a label for it's a type name we define. So actually we want to combine nullary function with function which takes a type a as an argument and is giving us a nullary function. Yeah, so let's do this. So I have already defined foo function. Yeah, so now I define a function f a b, let's call it like this, and my function f a b is defined like that. Okay, so I will get a, because here I have an int, so I will get an integer, and having this integer I return my nullary function with my integer turn into the string. Yeah, okay. And now when I combine these two things, I get a compilation error. Yeah, so we cannot use this combiner, but we have another combiner. We have combiner map, and I try to combine with my function, and I can do this, and this is fully correct. But that is what I have here. I have nested nullary function inside nullary function. Yes, it's nested. This is because to get the result of computation I have to call it twice, and then I will see that there's a string, and this is okay. But I would like to have a possibility to flatten this. Yeah, so I would like to have a combiner where I combine foo and fab. I will get just that signature. Yeah? So I will get nullary function is giving me string. So we need another combiner. Yeah, and I will define this combiner as fmap from flatmap, which gets types a and b. On left hand side I have an fa, or maybe ma. Yes, and this one is another function, and this one is my nullary function which is giving me a. I have a function f, or f. Let's do not confuse you with the same names, but it doesn't matter, can be the same. Which gives me b. That what I'm expecting is to get b. And as you can see, the implementation is really straightforward, because actually I'm applying ma to f. Yeah, and this is correct because my result will be the function. So we are still we are still in line following the rules of functional paradigm, compliant with them. Yeah, and now when will use a fmap on my foo and fab. Yeah, this is exactly what I want to get, which is cool. When I define another, I have a fab, maybe we'll call it fcd. So this time I would like to define a function which gets string. Yeah, and I return s to double plus 14, like this. Okay, and now I will combine them together. Fmap. Here I have my function foo, and here is my function fab, and here is a function fcd. Yeah, it's flattened. It's flattened. Yeah, so this is okay. This is exactly what I want to get. Yeah, to see that this is really correct, so let me call this guy. So I have again a correct result. In theory of categories, we see that the functor is a functor. No, excuse me. The monad is a monad if I have some m, and on this m I'm calling flat map function f, and I'm calling a flat map on G. It should be same like m calling flat map on x. So here I have a function which is giving me an x as same type is inner type of m of this m. Yeah, so this is okay. And now what I'm gonna do is that I call the function, my function with x. Yeah, so and I'm flatting, I'm flat mapping it with G. Yeah, so this is what I really want. So in our world is that if f is an a giving me b, so I can see that this nullary function giving me b is a result of application of content belonging to m, yes, and I expose it to f. So that's why I rewritten in this way. So how it will looks like in case of just the functions. In case of functions will be like so the first one, the first thing is just the fmap. That's what I wrote. It is fmap foo fab fcd. But on the other hand, I would like to change it a little bit. So I would like to check such situation. So I have a foo, and here I'm giving back. I'm applying a function which takes integer. This integer is applied to fab. Yeah, and I'm flattening map all of it. excuse me. Which is full. This int. Excuse me, it's not in this. Exactly. Sorry for confusing, because there is wrong place. Yes, so now what I have in it is like I have a flat map and I'm applying it on the full nullary function, and I create a function. Yeah, exactly. This is the content. This is what I said previously. So this is this guy. This guy. Yeah, so x and flat map. So this flat map is moved ahead here. So this flat map is here. Okay. Too many brackets or two? Yeah. Exactly. So when I called here result for thing, I will get exactly same thing. Yeah. So we are done. We have another category. Sorry for confusing. I also confused, so you know that it's not something really well prepared. But I prepared here. I'm not sure it will be visible. I prepared again this monad for you as a trait. So now I can write it. You see, I have a flat map. So we can write. We can use infix right in here. So for foo, I can call flat map, and I will put here fab and flat map fcd. And of course, I can rewrite exactly this guy. So in my case, will be foo flat map x. I'm not sure if I have to give a type. Probably not. F AB with applied x flat map fcd. Yeah, exactly. So we see that this is next category, and this is called monad in category universe, and at the end there is the monad can be whatever. Yes, the monad can be when we see, for example, sequence of some integer. Yes, sequence is not a function, but and similarly for functors, yes, when we see the type generator, which so potentially I can apply, or I can turn every structure, every algebraic structure which can be expressed as this sort of type. I can turn them into functor, or I can add the functor or monad possibilities or capabilities. And next time, a pretty similar thing I can do with applicable. Applicable is something which gives me apply function, and the first argument is my nullary function. So this is type f of a, and the second is also my nullary function f of a, but the inner type is really very specific. This is strictly the function. Yes. So here I have a type a, the function which type function with which gets an a and results with b. Yes, and this type is really very specific, so I can compose my nullary functions, yeah, with apply method only in case the second part of my function is inner type is a function. And I think you can do this yourself at home. Next time I'm going to show you something about arrows.